Hello everyone, this is Ben. Today we are going to talk about computer software. So, we are going to talk about this invisible force that makes the hardware useful. While hardware refers to the physical parts of the computer, software is a set of instructions that programs or that tell the hardware what to do. Without hardware, even the most powerful computer would just sit idle. So in this lesson, we look at system software, programs like operating system that manage hardware and basic operations, application software, programs we use to perform specific tasks such as Microsoft Word, Excel, and all web browsers. Shall talk about utility software, tools that help maintain and protect the computer, like antivirus programs or disk cleaners. So, together, by the end of this, I want you to be able to explain software and why it's important. You identify different categories of software and give real life examples of software we use in our daily life. Let me also explain to you some things about operating systems. Operating systems is one of the most essential pieces of software on any computer. An operating system is often called the heart or the manager of the computer because it controls how the hardware and software work together. While you turn on the computer, the operating system reads first and allows you to interact with the machine. So, in this session, get to know the functions of the operating system, such as managing files, memory, and hardware devices. Get to know different types of operating systems like Windows, Mac OS, Linux, Mobile OS, Android OS, and others. Why operating system is crucial for multitasking, security, and user interaction. Be able to define operating system and its role in managing computer resources, and compare different types of operating systems and their uses. So, computer software and operating systems is just a comprehensive guide to understand. I'm relating to today's lesson that today we are going to know we are just giving a comprehensive guide to understand computer software, operating systems, programming languages, and security fundamentals for IT students. So today's lesson is best for IT, though other people can join, but today let's give a chance for IT personnel. What is a computer software, or what is computer software? What is computer software? So, put your answers in the comment section or in the question and answer section. And don't forget to subscribe to this channel or sign up for accounts for detailed updates. So, what is computer software? So, software is a collection of instructions that enables users to interact with the computers and perform specific tasks. Without these programs, computers can't execute any operations. I'm repeating. What is a computer software? I'm saying computer software or software is a collection of instructions that enables users to interact with computers and perform specific tasks. And get to know, without these programs, computers can't execute any operation, or can't do, or can't perform any operations. We have two main categories of software. We have two main categories of software. One, we have system software. And system software, it controls hardware components. System hardware controls, system software controls hardware components. We have application software. Application software, it performs specific user tasks. I want to type certain document. I have specific application software I have to use. I want to do this. There is a specific software I have to use. Let's talk about system software and application software. System software, as I said before, it controls and manages hardware components, providing foundation for other programs to run. So without system software, other programs can't run. We have operating systems, device drivers, and system utilities. Don't forget compilers and interpreters as part of system software. Whereas we have application software. Application software performs specific tasks for users. Meaning they are built on top of a system software foundation. Meaning application software, they can't work without system software. One, we have word processors, spreadsheet, databases, web browsers, and others. Make a research about them and put them in question and answer section or in a comment section, those who are watching over YouTube. Let's dig into operating system fundamentals. Operating systems fundamentals. An operating system acts as an intermediary between users and computer hardware, providing an environment for programs to be executed. An operating system, it acts as an intermediary between users and computer hardware, providing an environment for programs to be executed or for program execution. So one of the fundamental, we have hardware control. Operating systems manage CPU, that's central processing unit. It manages memory and output or input devices effectively. Another point is user interface. System software, operating system, it provides interaction between a user and the system. So it's an interaction layer between users and system. As we control the computer, you have to have a layer for you to manage that computer. Let's talk about resource protection as a fundamental for operating system. Operating system ensures secure access to system resources, whereby it allows you to put passwords, to put any kind of encryption you want. Let's talk about two key operating system functions. Let's talk about only 4. 1, command interpretation. The operating system, it translates user commands into machine readable instructions and converts output back to human readable format. Because what you can really see and understand, a computer can't understand that language for you can understand. So we need an interpreter. We need someone to stand in between. So that's an operating system. Is in between the user and the computer. So what you give the computer, the operating system interprets and makes a computer understand. And also what a computer gives you, an operating system makes you understand. So it's an intermediary. Second, you have resource management. Operating system, it allocates the central processing unit, memory, and peripheral devices to process based on priority and availability. So it understands the command you have given and then assigns the operating system, assigns the particular sector to handle and the particular device to handle. We have memory management. Operating system, it tracks memory usage, decides which process to be loaded or to load, and handles allocations or deallocations. So it's upon the operating system to know what to be done, where and how to be done. And the fourth one is process management. Is that operating system, it controls program execution, scheduling, and resource allocation for active processes. Let's talk about types of operating systems. Let's talk about types of operating systems. We have single tasking, multi-user systems, and specialized system. We have single tasking, multi-user systems, and specialized systems. I repeat. Types of operating systems. We have single user systems, multiple user systems or multi-user systems, specialized systems. Those are the main three systems. Single user systems, that is single tasking. For example, Microsoft DOS, MS-DOS, it's one user, one program. We have multitasking, that is Windows. One user, multiple program. So under single user systems, we can have two, that's single tasking and multitasking. Whereby you can be one person using a computer and one program used. Under multitasking, like a Windows 10, Windows 7, Windows what? Is one user, but he may handle many programs. Multi-user systems, we have Unix, Windows servers, whereby multiple users accessing different resources stimulate. Whereby many people or many users can access the system and use it to do different functions or to do different activities. And thirdly, specialized system, we have real-time and batch processing. Real-time is strict timing requirement. You have to do certain work in a certain period of time. But batch processing, this one, maybe I can say groups similar to jobs together. So, those ones are basically the types we have. Let's continue. Programming languages over. Let's talk about programming languages. Programming languages are artificial languages used to write instructions that computers can execute. They form a hierarchy from machine to readable to human readable. So they change what a human being can handle or can understand to what a computer can understand, and then reverse back what a computer can understand to what a human can understand. As I told you before, that what you can understand, a computer can't understand, and what a computer can understand, you cannot understand, because the computer handles binary number system, and for you use human language. So we need someone to be in between, to act as an intermediator between a computer and the user. You understand the issue? So, one, we have machine language. Machine language is binary code, zeros and ones. This one is directly understood by the CPU machine. So this one, no translation is required, and it's a machine language. Machine language is under binary number system. It's directly understood by the CPU. This one is machine dependent. It's machine dependent. Another programming language is assembly language. Assembly language, it uses mnemonics and symbols. So this one, it requires assembler to translate to machine code. You need the assembler because of symbols that are used. You need someone or something to assemble the codes so that the computer can understand. Then you have what we call high-level languages. These ones are English language like syntax like C++, Java, Python. And these ones, they need the compiler or interpreter for execution. Let's talk about a compiler and the interpreter. A compiler translates entire programs at once. Interpreter translates line by line. It handles line, then after it goes to another line. But a compiler to handle all at once. A compiler creates executable file, while an interpreter, no executable file is created. In the compiler, we find the fast or faster execution time, while in the interpreter, less memory, less slower execution time with less memory required. Yet in a compiler, there is more memory required. I don't know whether I get the issue. In a compiler, errors out the entire compilation, while in interpreter, since it handles line a line, continues until a error is found. Example of a compiler, we have C++, Java, Python, and others. No, Python, no. We have C++ and Java. But interpreter, we have Python, have Java and JavaScript. So let's talk about this in details. This characteristic is that call prior, it translates the entire program at once. It creates executable file. There is a faster execution time and more memory required. We errors halt entire compilation. In interpreter, translates line by line. No executable file created. Slower execution time and less memory required. And it can continue until error is found. Let's talk about computer virus types and detection. Computer virus. You hear computer virus. What is a computer virus? Because we find it in our systems. Computer virus is the malicious software designed to replicate and spread, potentially corrupting data and compromising system security. I'm saying a computer virus is a malicious software designed to replicate, the spread, and potentially corrupting data or compromising system security. Because I don't want you to face challenges of determining computer virus. A computer virus is a malicious software designed to replicate and spread, potential corrupting data or compromising system security. And basically we have four main, though we have other types of viruses. We have boot sector virus. A boot sector virus, it affects boot records. It affects boot records of drives. They spread through infected disks and pirated software. That's why we discourage people from pirating software. Someone can send you software with internet virus to compromise your system security. We have what we call program virus. A program virus activates when infected file is opened. It activates when infected executable file, particularly, is opened. Infected file, this one, the one with the .exe, .com, those are the executable files I'm talking about. Thirdly, we have what we call a microvirus. A microvirus is embedded in documents commonly found in Microsoft Office files. Then, lastly, is polymorphic viruses. Polymorphic virus, it changes signatures each time. It duplicates, making detection difficult. How can we prevent viruses? How can we prevent viruses? Antivirus software. Keep updated antivirus learning continuously. And I can recommend Newton, Evig. I can recommend those two to be popular options. Use updated and always update your system with appropriate best antivirus software. Use firewalls, whereby install firewall protection to prevent unauthorized access and hacking attempts. Install firewall protection. Email caution. Never open attachments from unknown sources, especially executable files. As I told you that you have viruses that are from executable files. So, never open attachment from unknown sources. And lastly, regular backups. Maintain up-to-date backups stored in separate, secure locations. Backup your data. Always back it up. Thank you for your time. Let's meet in the next lesson. God bless you.